Can I just request everyone, if we can have the networking outside so that we can start with the session. A very humble request to all the people who are standing just very close to the stage. Please, if you can move outside. So we have our breakout session 1A, which is optimization, indigenization of electrolysis process for renewable energy integration. That's in meeting room 6, level 2. We have the breakout session 1C, hydrogen for defense sector. That's in room 9, level 1. And 1D session, harnessing green hydrogen through biomass-based pathway. That's at level 1 again, meeting room 10. Herein, we are starting with our breakout session 1B, which is on the conventional and emerging solutions for storage and transportation of green hydrogen. Our knowledge partners for this session, World Bank. Real apologies for this little disruption which we are seeing. It is We had to move the session here in this hall last minute, but thank you for supporting us on that. Please be seated for this session. Thank you.
Distinguished galaxy of dignitaries, eminent guests, stalwarts, and veterans of the green hydrogen ecosystem, a very warm welcome to the first in series of the technical sessions. In a minute or two, as we await the arrival of the eminent panel for the session, we shall be commencing with the proceedings for the session. Transcending from the notion that energy transition were a thought to be steered in the future notion. The dynamics and the volatile world today has made clean energy an epochal action for the present. Today, as we gather to mull over how to make reality clean, green, and sustainable future. Time now for an array of technical experts led session of deliberation. Unveiling now session on conventional and emerging solutions for storage and transportation of green hydrogen. And ladies and gentlemen, we have with us the esteemed session moderator, Ms. Surbhi Goyal, the Senior Energy Specialist, World Bank. And may I please request you all to kindly raise some noise and extend a resounding round of applause as Ms. Goyal now graces the days. Well, she's bringing along with her over 19 years of experience leading some of the most innovative projects in renewable energy sector in India. She's also been the one who's led the 3 billion US dollar policy engagement on green hydrogen and renewable energy in India, and the one who's been recognized as the Asia's most influential women in renewable energy. What a delight to have you with us. A very warm welcome. We're also overwhelmed to have with us an extremely exalted panel, whom I shall now request to please grace the days. And to begin with, it is our honor to have with us Mr. K.C. Sharma, the Chief Engineer, Ministry of Road, Transport and Highways. An exemplification of academic acumenship, a mechanical engineer from IIT Roorkee, a master's in energy studies from IIT Delhi, an MBA from FMS University of Delhi. Well, ladies and gentlemen, his expertise hails across various organizations of repute. To mention a few, the Border Roads Organization, the Tata Motors Jamshedpur earlier. Sir has been spearheading excellence and making way in the ministry for various path breaking alternatives for fuels, emissions in the safety of the transport way. A very warm welcome to you, sir. And just to make sure that if we are ready to welcome yet another exalted session of panelists, may I request you to raise a thunderous round of applause as we now welcome Professor Pratibha Sharma, a Cummins Chair Professor in the Department of Energy Science and Engineering at the Indian Institute of Technology, Bombay. Well, ladies and gentlemen, her able guidance has been enabling advances in the green energy research area, where she's supervised 18 PhD students, more than 45 MTech and MSc students, and has around 105 international journal publications and 5 patents to her credit, awarded the Outstanding Service Award by International Association of Hydrogen Energy. A very warm welcome. Warmly welcoming now Mr. Milind Agrawal, the co-founder and the Chief Executive Officer, C&D Midstream, an upcoming midstream infrastructure platform focused on developing supply chain infrastructure for green hydrogen in India and the other parts of the world. He brings along with him 2 decades of experience, transcending from being a senior emerging markets investment team member at the Global Infrastructure Partners India, with strong expertise across different subsectors of infrastructure, energy, utilities, transport, telecoms, and the list goes on. A very warm welcome to you, sir. And now, very heartily welcoming Mr. Savir Julka, the Global Marketing Head, Industrial Gas at INOXCVA Limited. A louder one. It is about energy. And if you find yourself in the right space, maybe please request you to show it. Well, ladies and gentlemen, Sir has spent close to 3 decades with the company to enabling it to become a global cryogenic solutions major. His illustrious stint has steered domestic and international business development for INOXCVA's wide range of high quality cryogenic storage and transport equipment, vaporization system packages, and expertise in high value techno commercial subjects. We're eagerly looking forward to hearing from you. And now, with utmost delight, may I now welcome Mr. Akhil Mehrotra, the Managing Director, Pipeline Infrastructure Limited. Ladies and gentlemen, a business leader in energy sector with over 31 years of experience across oil and gas, power and telecom industries. The chairman of the Mahanagar Gas Limited, a Fortune 500 company, Sir has been on boards of various eminent groups and companies, including the Shell Energy India, the Hazira Ports Private Limited. His astute leadership has skyrocketed business performance across organizations of repute. A very warm welcome to the exalted panel. And just before I hand over to the esteemed session moderator, may I also please invite Dr. Arvind, Scientist D from MNRE, and Mr. Gurpreet Chugh, MD ICF, as we shall now be having a release on report by ICF on green hydrogen production cost in India and the impact of incentives. Requesting the esteemed panel to kindly do the honors of this release and unveiling it to the August House. That, ladies and gentlemen, is the report on green hydrogen production cost in India and the impact of incentives. And just to give us a little more insight into it, may I please request you, sir, Mr. Gurpreet Chugh, MDICF, to kindly throw some light on the release.
Good afternoon, ladies and gentlemen. I think we have an excellent panel here who are going to talk about green hydrogen storage, transport, the opportunity, the challenges. And it is really my great pleasure to be able to launch a report in front of this panel and the August audience as well that are attending this session. ICF, ladies and gentlemen, is a consulting organization. We are about 50 years old. We are headquartered in the US, but have been in India for last 20 years, work around energy, climate, urban, transport, and many other areas. We've been working a lot on the green hydrogen space, and it's been our good fortune to work with MNRE to make this report on understanding the cost structure for green hydrogen in India and the various incentives that are being offered by the center and the states, and the impact of all those incentives on the cost of green hydrogen production. Uh, we had the opportunity also to interact with a lot of you in the industry while making this report. And some of the recommendations that were provided and suggestions that were provided by various stakeholders have also been incorporated in the report. So I'm going to give you a sneak preview on what the report includes. I'm not going to take a lot of the time because we have an esteemed panel who want to discuss about storage and transportation. But feel free to reach ICF and reach us to ask anything that you would like to, or even if you want a copy of the report. There'll be a QR code at the end of my presentation, which you can download the report online. Um, I'm going to just skip the table of contents, but the overall objective, as I said, is to look at green hydrogen costs in India and the impact that various incentives. There are a number of incentives that, as you all know, the site scheme came, it offered many incentives for green hydrogen production. And then we also have many states and their own policies on green hydrogen, which offer different incentives. So we tried to look at the impact of all those incentives and how the cost of green hydrogen uh, works with these incentives in place. For that, we created a model, which is a kind of a robust model to look at various elements of the value chain and the cost chain in green hydrogen, and has made certain assumptions based on projects which have been executed on ground. So the costs that we have included are based on projects which are being executed in ground. These are still small projects of the size 10 megawatt and so on. Then, on the basis of interaction with the industry, we've also scaled it to somewhat larger projects like 100 megawatt. Provide an opportunity to look at, let's say, something like a 1 lakh ton of ammonia production, the size of a project that you need. Size does have an impact on cost. So we've considered 100 megawatt electrolyzer for that. There are some other assumptions that we have looked at. I'm not going to get into these details, but I'm just going to talk about high level numbers. And if you look at the cost of green hydrogen without and with incentives, you start from a number like 475 to 500 rupees per kg of cost of production. But as progressively incentives are there and scale starts to make an impact, the cost starts to go down, and we reach something like 350 rupees per kg with all these central incentives in place, uh, if they are assumed for a 100 megawatt electrolyzer. If you look at the state-wise green hydrogen cost comparison, of course, Odisha comes out to be the best because they have many incentives which are quite good and better than some of the other states. The report talks about all these incentives that are there. The discom power subsidy that's being provided, the electricity duty, and so on and so forth, and 30% of plant and machinery that is being provided as subsidies and all. So what we analyze is that the states, based on where the project is set up, the cost of green hydrogen perhaps can be different, and therefore the state subsidies play quite a significant role over and above the central subsidies to attract project developers. We did a quick analysis with the cost of gray hydrogen, and what we kind of realized that for small projects, Odisha is actually reasonably competitive with the cost of gray hydrogen, assuming LNG prices between $12 and $15 an MMBTU delivered to manufacture gray hydrogen. Some of the other states have higher costs, and therefore the gap between green and gray hydrogen still remains in some of the other states anywhere between 50 to 60 rupees to even up to 150 rupees a kg. And this gap, we need to look at how to bridge this gap over a period of time. So all these numbers and all this analysis is available to you in the report. Some of the conclusions that we kind of drew from this analysis and our discussions with the industry, uh, many of them I already mentioned. I think the first one is economies of scale matter. So if we are able to aggregate demand for green hydrogen or green ammonia and build larger scale plants, say 100 megawatt and then going up to 500 megawatt and even a gigawatt kind of facilities, these economies of scale will start to kick in, and the capital cost impact on the green hydrogen cost will go down. There are, but apart from that, the electricity costs are most significant, as we all know. So, looking at how to optimize those costs will make a big impact on the cost of green hydrogen as well. Especially, for the current analysis, we've looked at the FDRE bids, but there are opportunities to look at electricity during solar hours and optimize the operation of the electrolyzers and green ammonia to match with the electricity that is available during solar hours. And as more and more solar energy gets built, and during the days the prices go down, even in the real time market, it provides an opportunity to kind of shift the production, instead of flat production, have more green hydrogen and green ammonia production, was subject to technical limits in the solar hours that can help reduce these incentives. And finally, of course, the carbon pricing, which we are all anticipating will come into play in India at some point in time. Depends on what the carbon prices will be. And as you know, they can vary a lot between regions. In China, the carbon prices have been around $8 a ton, $10 a ton. EU, they've gone beyond 100. So there's a wide variation in carbon prices. And where the Indian market and how it is set up will also impact how green hydrogen projects can obtain further monetization or options for support from carbon. Finally, I think coming to some of our recommendation, we are recommending a detailed national level assessment for green hydrogen. This has been limited to 3 or 4 states, but we are recommending a pan-India analysis for assessment of green hydrogen opportunities and challenges across states, and also to look at a very comprehensive green hydrogen production cost model, which could be an online tool that MNRE would host, and it would have a lot of flexibilities to be able to assess the impact of incentives and operations on the cost of green hydrogen. Coming on to some of the other recommendations that we feel will actually make an impact. is to look at sector-specific targets for green hydrogen consumption and green procurement rules as well. How we incentivize the demand sectors to consume more and more green hydrogen will be key in aggregating demand and, of course, creating the market for green hydrogen. Some demonstration projects with new technologies would definitely help, and aggregating demand, so large-scale production can, of course, be there. The hydrogen hubs have been planned. We are recommending to look at the augmentation of these hydrogen hubs. Also, to look at local distribution zones for hydrogen where these hubs are coming up, because there might be some industries in the vicinity who need hydrogen, and you can have small dedicated hydrogen distribution network kind of increase the demand in these hydrogen hubs. And then there are slew of other recommendations that we have mentioned in the report. Uh, this is the QR code. If anyone is interested, you can scan it here, or reach out to any of my colleagues from ICF who are here to maybe set up time. We are quite happy to come and meet you and tell you about what work has gone on and what are some of the assumptions behind it. And we'll be delighted to welcome any questions. Not now, but afterwards. So thank you, everyone. And I think before I end, I have to also say a special thanks to Surbhi and World Bank for launching this report in this session. And I think the MC introduced Surbhi as one of the most women leaders, one of the rising women leaders here. I think in green hydrogen today, she's perhaps the foremost leaders across India. And so it's great honor to have our report launched under her moderation. So thank you so much, and I wish the best for this panel and discussions. Thank you.
So thank you so much, Gurpreet, for the kind words. You made my day. And really, I think this report is coming very timely because as we are deepening the engagements like the investors and the developers, I think this consolidation of the analysis in which states where the potential lies is very important. So I think one of the things that we would like to zoom into one of the points that Gurpreet was mentioning is economies of scale. And economies of scale can come in when you have large scale production, you have large scale demand. And to meet that, you bring together a lot of infrastructure. And this is where we are talking about a very specific missing piece of the puzzle in the green hydrogen value chain, storage and transportation of green hydrogen and its derivatives. And we have a very good panel, very diverse panel, and we hope to unlock some of the, things that we have in our mind. Where are we heading towards? There are a lot of discussions happening around green hydrogen hubs. Of course, that is very important to begin with because you really need co-location of facilities of both production of hydrogen as well as consumption. However, you cannot always have both co-located in the same periphery. Still, it would require a bit of a transportation or storage. So even there, at sooner or later point in time, maybe at a different scale, this is going to become very important. And hence, today's panel would essentially try to look at some of these points. We will try to have a short Q&A towards the end of our discussion, and please be ready with your questions towards the end. So let me begin with it. With the first question going to Mr. Sharma, who represents Ministry of Road Transport and Highways here. Mr. Sharma, one of the important demand segments that are coming to the forefront is a long-haul transportation and trucks specifically. Now, there are a lot of challenges in terms of the technology in the vehicles itself as well as the hydrogen refueling stations which are required along the way. And some of the analysis do reflect that should we have transport corridors which are dedicated for green hydrogen, but a lot of ifs and buts are around it. What are your takeaways? What ministry is thinking? What are the bottlenecks you are facing, and how you think that these certain risks that we are at the moment facing in the industry could be overcome by certain interventions that you are planning to take, or globally, probably some other countries may have taken. So, what are your thoughts on it?
So thank you for firstly inviting and then making me a part of this panel. Now, before I begin to comment on the other issues stated by you, I would like to first mention the initiatives being taken by the ministry, our ministry in collaboration with MNRE and a reputed testing agency, Automotive Research Agency of India. So we are planning to undertake trials for motor vehicles, starting for heavy duty motor vehicles from 18 tons to 55 tons. And in addition, we also propose to have trials for the light vehicle segment, that is M1 category, as we call it technically, that is vehicle less than 3.5 tons. Now, both these technologies, fuel cell as well as ICE, have been offered for the purpose of trial in both the truck segment as well as in the bus segment. Bus segment, we are trying to have the trials for 9-meter and 12-meter buses. And the trucks I already mentioned, from 18.5 tons to 55 tons. Now, what is the purpose of the trial? The purpose of the trial is to assess both the durability of the buses and the performance of the buses with this alternate fuel. Why is the trial so essential? We all know that hydrogen has some typical characteristics. From our school days, we know that hydrogen is a colorless and odorless gas. In addition, there are technical challenges also. It has got a huge flammability range in comparison to other fuels like natural gas and gasoline, for that matter. So, the handling of hydrogen, along with this, the very less ignition energy required to ignite the fuel, makes this fuel very typical, and lot of care and caution must be taken to undertake the trial. However, we have come after extensive discussions and deliberations with all stakeholders. We have come to a stage where we have decided to undertake the trials at 350 bars, not less than 350 bars, 350 bars for the onboard storage devices. Now, the storage devices again can be bulk storage devices and onboard cylinders as a storage device. Now, this fuel, because of its limited density in volumetric terms, uh, we can't transport it from point A to point B. So we, at the dispensing station, we require chillers as well as compressors to build up the pressure to 350 bar. Now, the routes have already been identified. As of now, the storage and dispensation facility is limited in India. It is either available in Baroda, Jamnagar, Faridabad, some locations in close to Jamshedpur. However, we are trying to ensure, with the in consultation with PESO, which is the regulating agency for certifying these storage cylinders. So we'll be uh, trying to rather extend the limits of pressure from 350 to 700 bars. Globally, 700 bars tests in Korea, in Japan, in UK, and in parts of US are are underway for at 700 bars. So we would like to reach that level. Whole idea is that we achieve the maximum potential in terms of range when we use hydrogen. Now, the second point I would like to mention is that after this entire trial exercise is over, in this, we also plan to extend the trial to the construction equipment vehicle segment. Uh, many of you must be aware that uh, many well-known companies, backhoe loaders have been tried, excavators have been tried, and uh, 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 some special purpose vehicles have also been tried on hydrogen. Now, in a typical mining kind of an application where the usage area is very limited, if the storage facility or bunks are created where the hydrogen can be stored, they can be of great use uh, in the area where it is intended to be put to some kind of use. So at this stage, I would like to limit.
No, that's very important, and actually, it gives me a good segue to move on to the two players who are here, who are actually into the storage space through their cryogenic solutions. Let me pass on the question to now Mr. Savir Julka, who's representing INOX. Mr. Julka, so Mr. Sharma, do have that kind of um, basically understanding of the ecosystem that storage and all are going to come and will play a very important role. Do you think so? We all think yes. And what are you doing in this space in the sense that you have already operational commercial facilities up and running? So what is that enticed you to get into this business so early on? Because at the moment, there are not much initiatives and incentives being taken to promote storage. But you have gone ahead and taken that stride. So, what have been your learnings from this entire process and the bottlenecks that you see for scaling it up? Because we all are aware that storage is something that people are, trying to figure out, but still remains an unsolved mystery. You have certain solutions for us. So we look forward to your interventions on it.
Thank you so much. For those who don't know us, Inox is a large group, and we, Inox India, is a part of the group specializing in, as you mentioned rightly, cryogenic storage, distribution, and transportation range of equipment. We are a 32-year young company, young company, and we started off with building cryogenic equipments for oxygen, nitrogen, argon, carbon dioxide, nitrous oxide, and quite naturally, well, way before this entire hydrogen wave came up, we've been working on the hydrogen and helium field, liquid hydrogen, liquid helium field, working with the space project like ISRO and other areas where hydrogen has already been used, not only in gaseous but in liquid form. For example, about 6 to 8 years ago was the first time we built and supplied liquid hydrogen storage tank for converting all the material handling forklifts at Walmart and Amazon in the US from LPG to hydrogen fuel cell powered material handling systems. And to fill up these tanks at night, these all used to come and park near the mother tank, the mother liquid hydrogen storage tank built and produced by us, engineered in India, produced in the US, and supplied to the US customers. Similarly, if you know about the satellites that are being launched every now and then, that's from the second satellite launch pad, which has a larger ballast or a blast off capacity. There, the entire rocket propellant fuel handling system was our project done way back in 1999, which included liquid hydrogen storage and complete fuel management system. So we've been around for more than you can think of in the field of hydrogen and helium, and hydrogen has been around longer than anybody could think about, especially in petrochemicals, in refineries, and in even in space. Now that's about where we come from in our capabilities and experience in storage systems. What made us come here is very natural. For instance, 2 decades we have been the front runners in offering LNG cryo value chain systems. So when the natural gas pipelines came in, and then when the scale of distribution and the distance of distribution increased, they needed more density to go, more molecules to go instead of the metal that carried the high pressure tankers and trucks. So it became in the liquefaction domain, and that's where we came in. We were among the first ones to produce the LNG storage tanks, transport tanks. Even the some of the first LNG refueling stations in India are from Inox. We have been doing testing of LNG fuel tanks on locomotives. We are among the leading LNG fuel tank for marine applications. So, in the European Union, when the vessels come into the coastal area, they are supposed to follow the environmental norms. So, they have to switch from fossil fuel or this diesel fuel to LNG. So, they had to do a retrofitting of the LNG fuel management systems on these vessels, originally designed for diesel or the oils, and switch over to LNG. Once they go back in the deep sea, they are switching back to the normal fuel because the bunkering facility was not available. Few years later, the infrastructure developed, the bunkering facilities came in, and we came in with the largest tank that could be fitted on a ship, 8 lakh liters. Let that sink in. 8 lakh liters is about the length of a ship. 3 such tanks on a ship are doing the bunkering job of providing LNG to the LNG fired vessels, fuel vessels, just as the conventional oil bunkering is going on all over the world, in many places, even by unmanned stations. My case in point is soon or later, the hydrogen energy platform will evolve and develop to a stage that it will have to carry in liquid form to distant areas, large capacities, and the infrastructure will build to accommodate storage systems, bunkering systems, and other marine systems and transportation systems.
So just a follow-up question. So are you at the moment doing any kind of such transportation yet, or you are looking to enter this space for hydrogen specifically?
In India, no, because India is still talking. We heard in the first session a lot of plans, developments, government support, and private party participations. But the discussions are are all at the moment hovering around production of hydrogen, cost of hydrogen, and then distribution in, as Sharma ji rightly mentioned, in gaseous compressed form. It's not come to the age or stage where it goes liquid. So we are on the bylines at the moment. But that said, in contrast and in comparison, the South Korean government, when they similarly went into the evaluation of the hydrogen domain, did a complete check on capex versus opex, the advantages of going liquid from day one versus the conventional gas systems. And you will check the published domain, they went the liquid way. So the first 5 tons per day liquid hydrogen plant that came up in Changwon was in a private partnership with Doosan Energy, but it had the government involvement for buyback of hydrogen. And no price for guessing who gave the tank. We gave the 240,000 liter liquid hydrogen
Not
tank.
8 lakh liter one.
240,000 liters, 40,000 liters tank. But very closely, that was in 22. In 23, last year, we delivered 4 tanks of 311,000 liters for the SK Group project, where they are doing a 90 tons per day production, and they also have a buyback arrangements with the government.
Yeah, I
So we are
think,
there.
yeah,
Yeah,
this is a very valid point. I think some of the lessons that we should definitely chalk out after this session is that buyback is important, which gives more confidence for the players to come into this space, which are not necessarily always fiscal incentives, but it gives more confidence to the players in the market. So with this, let me segue into another speaker who is here from C&E Midstream. Mr. Milind, you have been actively working in Indian space on such solutions. So what are your takes? We are very happy to see that INOX is looking at this particular segment in India, but you are already in here. So what is that that you can share with us on that?
Sure. So, as you know, am I audible? Yeah. So, as you know, in the hydrogen value chain, ammonia is one of the large constituents. And as CNE Midstream, our entire focus is only on ammonia supply chain. INOX specializes in cryogenic liquids, such as LNG and other low temperature materials. Our focus is entirely on ammonia. As a group, so CNE Midstream, as a quick introduction, is sponsored by Mysore Ammonia Group. It's a group that has been around for the last 60 years. We are the largest distributors of ammonia in India. Our customer segment is the non-fertilizer industrial segment, which is widely spread and has distributed fragmented demand. So we have been in the business of handling of ammonia for many, many years now, both in terms of bulk handling as well as handling over long distances in terms of smaller quantities. So coming back to your question, Surbhi, so ammonia as a use case for hydrogen and for this new industry is something that is already well established. The supply chain for handling of gray ammonia globally is very well established. Even within India, uh, if you look at the spread of demand for ammonia and the way ammonia is handled, So the largest consumption is in the fertilizer segment. Within fertilizer, you have two large demand segments: the urea-based fertilizer, the nitrogenous fertilizer segment, and the second is the DAPs. All the nitrogenous or urea plants typically produce ammonia on site because they are supplied with domestic gas. All the DAP plants import ammonia, and therefore you will see all of these plants are located at ports. And historically, all of these plants have had their own storages at integrated into their production sites where they have been importing ammonia from various global sources, Middle East, Russia, and elsewhere. So, and if you look at the global trade of ammonia also, it has been going on for a long time. It's a very large volume. So globally, this business has been in existence for a long, long time. Now, what will
So
change?
let me just
Yeah,
fine tune the question that
yeah,
what specifically you are doing in the green hydrogen
sure.
or slash green ammonia value chain, and do you have any specific industries that are requesting you to supply that?
Yes.
Of
So,
course,
yeah,
for you, ammonia handling is like whether green or brown or gray doesn't
yeah,
matter, right?
yes, yeah,
So what specifically demand centers that are coming to you
right.
for the transportation of ammonia?
Right. So yeah, I was just coming to that. So this new industry that is getting created, which requires a whole new solution, is what we are catering to, which is the upcoming green hydrogen, green ammonia producers. Now these plants again could be located. Most of these plants are coming up near ports. Uh, when all of these plants initially got conceptualized, their business case was based on export of ammonia. It's only recently that the discussion around domestic supply of ammonia has started with the launch of the SECI tender. So now with the customers that we are speaking with, potential customers, which are the upcoming green hydrogen, green ammonia producers, the discussion is around how we can help them in midstream part of the value chain. So as producers, they are upstream. As storage and logistics and transportation service providers, we are midstream. Within India, we also have a downstream platform, but that's not what we are discussing here. So our solution that we are looking to offer to them is how we can help them with the storage infrastructure near ports, which is absolutely important for them to be able to load their cargoes onto vessels for international dispatches. Similarly, when they are looking at domestic supplies, they need different types of transportation solution, whether it is road or rail, for movement of ammonia or even coastal shipping for movement of ammonia from their production sites to wherever the demand is going to be. And restricting the discussion only to larger size of demand. So, the SECI tender is for a quantity of roughly 7 lakh ton. Each customer is looking at a minimum offtake of 25 to 30,000 ton. So anybody who's talking to us is talking to us for this scale of demand or more, and therefore the solution that we are discussing with them, depending on the distance, depending on the regularity of supply, as far as domestic supply is concerned, is either road or rail, potentially coastal shipping also. And for long distance, it is about it's a infrastructure which is more of a transportation infrastructure than energy infrastructure. So how do we build that infrastructure for them is the topic of discussion.
Yeah, so I want to come back to some of the speakers on the challenges that they're facing in scaling up or any kind of policy regulatory bottlenecks that they would like to highlight upon. But let me first move on to Mr. Mehrotra, who is representing Pipeline Infrastructure Limited here. Mr. Mehrotra, we have spoken about like cryogenic solutions and all, but there is a bigger, requirement to be transported in terms of the pipelines infrastructure. So when World Bank and in association with ICF was working with the Petroleum and Natural Gas Regulatory Board, we realized that blending is possible in the natural gas pipelines for the existing network, but there are certain limitations, and more so from the safety perspective of the end consumers, what kind of equipment would need to be changed at the end consumer level, and then, of course, how we can shift towards the 100% hydrogen-based pipelines. So can you give the audience a flavor about what PIL is looking at it, how, you are trying to address this? Of course, you are looking at the market. So there must be certain thoughts about it, certain learnings coming from other, countries. So what is that PIL is looking at in association, probably other players or the ministry?
Okay, thank you. Thanks, Surbhi. And let me give you the audience little context around why we need this hydrogen blending. And we all know that energy demand is growing very fast, and we need hydrogen. The kind of and then it's said in the country, the energy trilemma we have is for we have to have energy which is affordable, sustainable, and also secure. Right. So hydrogen has a lot of these components, and I think we talked about affordability, the pricing of hydrogen, and we're hoping that someday from $4 to $5 a kg, it will come to $1.50 to $2, and I think that will take some time, but we'll go there. However, the good thing is that we can produce green hydrogen through naturally available resources, although there have been concerns on water, but we'll talk of that. Uh, However, we also should remember that other energy vectors other than hydrogen, like coal and gas, will continue for next 3 to 4 decades, and before the transition happens. Uh, and coming to the natural gas, India has approximately around 25-30,000 kilometers of pipeline, most of them underutilized today. If I can say that, the utilization factor is to the tune of 30 to 50%, other than one of the pipelines. So what can we do? And as coming back to the hydrogen blending, at PIL, we have done some work with DNV, a desktop work to say, can we blend hydrogen at different percentages, from 5, 10, 15, 20 to 100 percentages. The desktop work, which took us some time, uh, has come out with the opinion that we can blend hydrogen up to 8% in the pipelines we own, without any major modification and minor changes. Um, However, we can go up to 20% with minor changes, and not going beyond 20, because worldwide we'll talk of that why there are limitations around it. Uh, the limitations are also coming because our co-panelists talked about that hydrogen is lighter, more flammable, and we have to be more careful when we develop standards. So we have looked at it from the perspective of permeability. We have looked at what kind of issues our metallurgy will have if we blend hydrogen. Also, other tests which we have to do. However, if I can bring in the global experience here, I've been working with National Gas in UK, and they are much ahead of us. I'll say at least 4 years ahead in terms of testing. They have moved from desktop work to a real testing grid in Spade Adams in UK. I visited them few times. Recently, their phase 1 report has come out, which is known as Future Grid. The result says that you can blend hydrogen in the pipelines, and they had metallurgy from, I think, X50 to X65. We have X70 also here. I'm talking of steel qualities, and there's no problem blending till 20-25%, but they can go to 100 also with some modifications. So in short, without going to technical details, blending possible from 5 to, I'll say, 20%, uh, with minor changes. However, in India, the next step is that we have to go step by step to really first do a holistic desktop work, and then set up our own testing grid, take PESO approvals and other thing. I can describe all this in details also.
No, that's very
Yeah.
helpful, and it's very encouraging to know that you all are taking initiatives to start looking at the testing facilities and examples from others, and how to learn from the things that they have already done where they have been successful and customize it for the Indian case. So this is helpful. Now this actually takes me to Dr. Pratibha, who has been leading the efforts on R&D side of the metallurgy and bringing newer technologies to the forefront. So, Dr. Pratibha, you have heard about the what the interventions of other panelists have been. I'm sure some of that are integral to the part of the problem that you're trying to solve by bringing more R&D and doing more kind of testing in IIT. So would you like to expand a bit more on what you are discovering as you're getting deeper into this particular segment? What looks more promising in terms of that if you start an R&D for certain chemical compositions or metal compositions, which look like more promising in the Indian context, which could be indigenized, for instance. So, we would like to know more about it. Thank you.
Yeah, thank you, Surbhi. First of all, it's my pleasure to be a part of this esteemed panel. So my co-panelists, they have talked about the conventional technologies of storage, compressed storage, type 3, type 4, 350 bar, 700 bar, and liquid state storage. We at IIT Bombay, so again, my group is younger than the INOX group. So we have been working for last 20 years onto a different technology, which you can call a technology which is at nascent level or in maybe it's a disruptive technology wherein we store hydrogen in materials form, different materials, and they charge and discharge or reversibly store hydrogen. As against the conventional technologies, there are different promising attributes to it. We have very high volumetric capacity, storage density. That is the biggest advantage. As against compressed, wherein we can have 40 kg per meter cube, we can achieve 100 to 150 kg per meter cube of storage density. So the systems becomes more compact. These are safest as against the other methods. Reason being the charging and discharging, there is an thermodynamics involved and the release is endothermic. So if there is a leakage, it will stop on its own. We have the biggest advantage looking at the current scenario is that we find the problems associated with uh, non-availability of hydrogen refueling stations, and that makes a supply demand problem that we may not have more of FCEVs because we do not have hydrogen refueling stations. So herein we could address that issues because our systems operate at close to ambient conditions, temperature as well as pressure, slightly higher, maybe 30, 25, 30, 35 bar. So we can use the electrolyzer output, which can be directly connected for such to such tanks for storage. So herein I bring in this panel an expertise from materials as well as systems for storage. And we do work on a wide variety of materials which have very good properties and they can have wide variety of applications as well. Like we all know that there is a problem of capax with the mechanical compressors. Herein they can be used for non-mechanical compressor, for thermal energy storage, for hydrogen purification, for definitely for hydrogen storage, but it can also be used for onboard as in a vehicle as for onboard storage. So this is like we are working on different materials, taking them from laboratory to in fact a larger scale demonstration. So we work starting from computational to small scale to large scale, like hundreds of kgs we can make of such materials. And we can also develop storage canisters, which also ranges from a few grams to 50 kg or more than that of storage of hydrogen. Herein we do all sorts of things indigenously. So that makes the cost reduction. So entirely indigenized production of canisters as well as materials with the materials which are available in the country. So the biggest challenge with such materials was we were importing, and these were including rare earths. Because of that, we were heavily dependent on imports. But now with our materials, we are using the industrial grade materials which are available abundantly in the country. And through several projects, we have brought down the cost by 95% and have that capability of indigenously making both canisters as well as materials. So I hope that I'm able to answer your question.
No, thank you so much. This is very helpful. I think very important point that you made is that the more you indigenize, the more cost savings you can get, and the better the cost parity between gray and green hydrogen, right? So I think that's extremely important. I would like to go back to Mr. Sharma because you have touched upon a very important point, Mr. Sharma, which I had kept in my mind in a parking lot to discuss again with you on the safety aspects. So I think the properties of hydrogen that you mentioned are well known, and people sometimes quote the examples of certain explosions that have happened like few decades ago, and that had put the hydrogen story to the back burner. Now it's coming back to the forefront. So what, from your perspective, as a legislative body and as a ministry, what do you think is important to be considered, and what are the steps and the safety measures that you are at least thinking about to be enforced when such kind of vehicles hit the road? So be it on the trucks or be it on other kind of facilities which will be using the vehicles. So Any thoughts on that? Any insights would be helpful to know.
So far as safety is concerned, any motor vehicle before its launch, the prototype undergoes a testing from any of the testing agencies that is mentioned in our Center Motor Vehicle Rules, the most prominent among them being Automotive Research Association of India, International Center for Automotive Technology, and few more testing agencies. Now, the vehicle is required to be homologated for from the point of view of safety, from the point of view of emission compliance, and only it is once it is tested in accordance with the standards established, the vehicle is allowed to uh, the type approval is granted, and that type approval is uploaded onto the Vahan database, and based on the type approval granted, the inventory of such a vehicle can be uploaded by the OEM onto the Vahan database, based on which the registering authority can register the vehicle. So that is the scheme. Like
So if
now,
I can just clarify my question a bit more and bring more nuance to green hydrogen-based vehicles, anything specifically that is being looked at beyond what is there? Yes, that would be helpful.
now the point is the essential challenge revolves around uh, the pressure requirements. Right now, we have decided that we will not go below 350 bars, whether it is onboard storage, the Type 3 cylinders which was referred to. Now, some localization has come up, but Type 4 cylinders, in my opinion, is the lot of import is being done to manufacture Type 4 cylinders, and uh, therefore that is one requirement. In addition, uh, uh, the testing requirements, the testing infrastructure needs to be upgraded in some cases, because unlike the glass enclosures within which the dynamometers are allowed to test the engines, in this particular case we need concrete enclosure, so that in case of an explosion or something, there is no collateral damage. Now, that upgradation of testing infrastructure, testing facilities for hydrogen cylinders, Type 4. So these are the areas which are being looked into, in addition to other requirements, general safety requirement that we do for any particular category.
Great. Thank you so much. Thank you. That's very helpful to know. Let me move on to Mr. Milind. Mr. Milind, can you also help us understand a bit more on the quality control systems that are paramount for utilizing cryogenic based solutions, which you are already adopting in your business operations?
So, so I think when you talk of quality control, there are two aspects. One is the product quality, and second is the process parameters. So, I think as far as product quality is concerned, again, ammonia has a global standard of 99.5 to 99.8% ammonia concentration, which is which is followed, and with some allowances for foreign materials. So because it's a closed loop system, overall, I think those parameters have to be, get managed quite well in terms of the system design, and you don't see that to be a challenge. And again, this is a very well accepted global standard. In the SECI tender also, I think for the various off-takers, they have defined the ammonia quality requirement, and which are, in this range, 99.5 to 99.8. And as long as the supply chain integrity is ensured, you know, in terms of storage and handling, those standards should be met.
So follow-on question to that is that do you think that we have enough infrastructure facilities to ensure that as green hydrogen is scaling or green ammonia in your case is scaling up, we have that kind of facilities coming up or catching up?
No, so those facilities, like we are one of those developers
In
that going
terms
to
of the
be
industry, like the scale is going up in
no
that.
scale. Yes, so so we are currently working on 2 or 3 storage terminals, which will be multi-user facilities, and each of these facilities, uh, has to be properly engineered, and there are global tier one EPC contractors and engineering firms that do undertake the design and engineering of these facilities. So uh, and these facilities then take about 2 years to get built from the time you start the construction, and then there is time required to procure the land and to receive all the approvals, to get through with the permitting process. So it will have a 2.5 year kind of a time frame. As far as the storage infrastructure is concerned, trucking is, truck tankers are already available. So those
As per you, the ecosystem is geared up to meet the demand.
ecosystem, no. So in fact, that's one of the points, because one doesn't know really when, each project is going to start, because today there is a bit of uncertainty on that. Every project is prepped to, to take off. FIDs have not happened, NTPs have not happened, because optics have not been signed. So everything needs to be planned based on when these projects are going to come up.
Okay, sure.
Thankfully, from storage point of view, just to complete the point, our timelines are shorter than the timelines
Which helps
for
the most.
building the production sites. So we should be able to manage within those timelines.
Because in
Most cases.
renewable energy, it's the opposite way. You put up the solar project, which is much faster, but the transmission line takes like longer,
Yes.
which is like chicken and again.
Yeah.
So let me go back to Mr. Julka. And what are your thoughts? Because you are now looking at India as one of the very promising markets. What Milindji just mentioned. Would you like to just expand a bit more on what are the challenges you are foreseeing when you are looking at this particular market? Of course, FIDs, FEDs, it's the problem globally. It's not specific to India, but still a lot of, as we were looking at the presentation today morning, we saw that 7.6 million metric tons of deals have been announced. Some of them are being closed, like we recently heard about some of them in the news. But what is that you would like to see happening in the market, which would allow you to enter and scale up?
I think intellectual property and experience, detailed investment, and focus on R&D development is what makes companies like ours and our panelists around here, succeed in offering foolproof, safe solutions. The challenge that we could face is similar to what we saw during the COVID time, when you all heard that there was a scarcity of equipment for oxygen transportation. And overnight, the PESO, who's so strict in giving approvals, gave overnight approvals to Tom, Dick, and Harry's. 15, 20 companies were given approvals to make pressure vessels for oxygen. And out of that, sad to say, probably only one or two are still existing around. So that's a big challenge. I mean, you have to be regulating, there has to be a self-regulation, and there has to be a very strong penchant for safety in each direction. When we developed the LNG fuel tanks for Caterpillar as an OEM, before it could be put on commercial use, for a year and a half, we sent prototypes. They lifted it with high cranes, put the whole tank on fire, filled with LNG, dropped it down. It was fireball impact tested. As we speak, few years ago, before we could enter the hydrogen domain, we sent 3 tanks to a test facility in Germany. They put these 3 tanks one by one on propane burners. They were put on fire with hydrogen inside. And it was noted second by second or nanosecond by second for developments, changes in the inner vessel, which is a cryogenic inner vessel, insulation, vacuum, and outer vessel. It's a double wall. Deterioration of inner vessel, blasting of the outer vessel, implosion, temperature rise, everything. So the engineers know what is a worst case scenario that can happen before you put such a product in a commercial use and in masses. So ERs, emergency response procedures, are also developed based on the behavior of the tests. So these facilities should be supported. These are not available in India, so you have to send them out. Today, I have to test a hydrogen tank with liquid. There is no liquid hydrogen available in India yet. So these are the challenges and areas that could come as bottlenecks.
No, thank you so much. That's very helpful. And hopefully we have certain colleagues from Iminari also attending this session. And it will be one of the key points for us to take back to them. Mr. Mehrotra, so when we talk about the pipelines, and we have spoken a bit about the safety and the challenges that we are facing. So from the pipeline perspective, how we should approach in retrofitments of the pipelines, if at all we have to do that. You mentioned about the blending without least kind of changes up to 8% and then could go up to 20% also. Certain research studies do claim so with minor changes. But in terms of how to begin, where to begin, I think there is where is again a bit of an aspect of safety that creeps in. But beyond that, is India equipped with the testing facilities and the equipment to do that kind of testing? Or we can't just take the section of the pipeline, the current pipeline, and send abroad and to get the testing done and come back. So we have to have certain facilities. What are your takeaways on that?
Okay, we need to take a step approach. Now, as a company, we have done a lot of research on our pipeline, but that's not enough because pipelines are a grid of network and we exist in an ecosystem. So we can't inject something in my pipeline and not worry about others. So we had recently discussed this with PNGRB also, and they're working on it. They visited Spear Adams with us so they could themselves see what is happening there. However, a two-step approach is required. The first step would be that all the natural gas pipelines in India, which includes owned by PIL, KL, GSPL, IOC, and few others, we have to take data from all these pipelines, the operating data, their metallurgy, their walls, the compression systems, do a desktop work first. And there are a lot of agencies in the world who can do that for us. That should take us almost maybe something from 6 to 8 months. Once that desktop work is done, that desktop work will throw out what are the weak points for us, which are the pipelines which are older enough, or the data from ILIs like pigging is not conducive for even injecting 5% hydrogen. So that will throw us the weak points. Using those sections, then we need to develop. That's the first stage. Then we move to second stage, which again will take us 2 years. That we develop a test bench ourselves in one of our facilities, which includes all these different types, different grades of pipeline, different compression systems, different walls, different maybe kind of metering systems which we use currently for natural gas, test them and then see. We don't have to reinvent the wheel. We can take a lot of data, which UK is front runner in that. They have published their results. We can use that results and expedite our testing. But again, we're still 3 years away. We have to demonstrate it in India based on our equipments, our type of pipelines, and obviously get approvals from PESO. But I need to add there one more thing that which I forgot in the last question, that while these pipelines, I'm sure, can take 5 to 10% blend without much changes, the ecosystem of customers are not ready, right? Can fertilizers take 10% blend? Can refineries take that? They have to also be ready, along with the use cases should be ready. City gas, good question. Other than CNG, we are hopeful that industries and they can take. CNG with type 1 and 2 cylinders can't take more than 2%. So what is important is another testing which is happening in UK in the same facility is deep blending. What deep blending and technology for deep blending is there. It only has to be available on a smaller scale at a commercially viable prices. Now, once we inject, so for example, 20% in our pipelines, we need to have deep blending facilities at a lot of customer ends. It will do two things. One, once you deep blend hydrogen and natural gas at certain facilities, the deep blended hydrogen can be used for vehicle filling stations. And we have heard that we are testing the deep blended natural gas can go to some of the facilities like CNG, maybe fertilizer to some extent. For urea, they say they can't take more than 5% hydrogen. So it can go there. So deep blending is a very important thing in the whole jigsaw puzzle. So that work is also going on in the world, but we don't have to reinvent the wheel. We can take the results from them. So I think the whole ecosystem, other than us, also has to be ready. But we all have to work together from now on. It will take us 4 5 years to reach that kind of thing.
Thank you so much. This is extremely helpful. Let me just move on to Dr. Pratibha. So, Dr. Pratibha, again, I am deliberately putting you towards the end because you are the one who brings newer technologies to the forefront for the audience to know what you are working on. So, you know, what we heard in the second round of conversations about the safety, about deblending, about, you know, these certifications, so to say that, yes, this technology is good, safe enough to be rolled out. What is that in your R&D space you've come across would be very, very important to be done at the central level to basically emphasize more upon expanding the testing infrastructure, R&D infrastructure, which could bring some of these suggestions much more in advanced manner than probably it would come in due course of time on its own. What are those steps or those interventions that would be required to solve some of these, risks or some of these challenges that the industry players have just mentioned? I know this is impromptu question. I'm sorry for that.
Yeah. So actually, if it is my technology, I would have said it is the safest one. But see,
Based on your experience, of course, your technology you have made safe due to certain, challenges which you have come across. So what is that differentiates your technology with the others could also help the audience to know more about it, right?
correct. So if I start with my technology, this is because the processes involved are at low temperature, are at low pressures. So we do not have to worry about pressures of the order of 350 bar or 700 bar. So we don't have to handle, and we do not require materials which could hold that pressure, because again, if it is 700 bar, the factor of safety makes it beyond 1000 bars. So that makes it safer. Other than that, the added on safety feature is that release is an endothermic process, so that cools down the system. And as soon as the system cools down, the reaction of release of hydrogen stops on its own. So that makes it safer. Now, when it comes to a general about any of the testing facilities, definitely we do not have test facilities. This is on behalf of my other uh, colleagues in different IITs as well as my IIT. If we could talk about the type 3, type 4, we are still struggling with the test facilities, but definitely this is a very good move by the uh, MNRE, wherein in National Hydrogen Mission, 200 crores has been identified for developing such test facilities. But still, I will say this 200 crore is very less. So at present, anyway, this is some step forward, so that I am very much happy for it. And at present, definitely the scenario is that we have to send these type 3, type 4 tank, whosoever is developing, for testing abroad. So it has to be in India. It may take time. So such initiatives as in the morning itself, R&D funding is less, or the test facilities development funding is less. And Dr. Bhalla, he pointed out, okay, we will make it double. So I think that is a very good step in that direction, that I hope will make that accelerate that transition.
I have been asked to shut down now, it seems. So yeah, this turned off my mic, which is interesting. Okay, so no, I was smiling while Dr. Pratibha was intervening, because I recall the person who was trying to make a very important point to increase the R&D budget from 200 to 400 crores. So I think it was taken in a lighter note then, but I think it's very critical, because as we are hearing from this panel, who are like top technical advisors and experts in this field, testing is extremely important. We are running a little bit short on time. Probably we can take two questions from the audience, just two questions. Can someone please pass on the mic to the colleagues on the left? And no, but none of others would be able to hear them. Please introduce yourself
Yeah.
briefly, and then you
Good
can.
afternoon. I am Baljit,
And
Director
sorry,
CHT.
if you can restrict your question to one sentence, so that we
Yeah.
have time to respond.
So the panel discussed about the existing pipeline network for blending. So that will be really good. The existing infrastructure we can utilize for the green hydrogen or hydrogen. But the point is that fixed number is not coming up. So one side we are saying 8% is safe. Then again we are, not so clear. We can go up to 20 also with minor modification. Then we say 2%. This number clarity, if can be, brought more, it will help actually to fix a proper guideline. That's enough.
Okay. So let me answer this in parts. First, when I said 8%, that's for my pipeline. And I then added that this doesn't help because all other pipelines which are interconnected to my pipeline should also be ready. So that nobody has a clue, and I'm very clear that whole work needs to be done, and we are just starting that work. 20% to 25 has come from global studies. This is from UK. National Gas has a huge network of pipeline with similar material which we use from X50 to X70. So we have reasons to believe that you can safely blend 20%. When I say they don't have CNG, so let's remember that. So we have a problem in CNG. So they believe that the gas which goes to household, to industries, they can take 10 to 20%. Now, while I say this, India has to done their own test. And once we do our own test and our own pipelines, own walls, and all my sealing systems, then we can say what we can blend in our network system. As well as I pointed out, there are hurdles from certain customers, like CNG cannot take more than 2%. So while pipeline can take 20%, I'm very confident of that with minor changes. At some of the customer ends, we need to deblend and then supply them either pure hydrogen or pure natural gas, whatever they need. I hope I clarified that.
So just to add one more point to what Mr. Akhil just mentioned. So PNGRB is by they were very actively looking at the space to see that what percentages would make sense for Indian context. NTPC has done one pilot project in Kawas, but it's at the CGD level. We haven't come across any, even global experiences where the blending is happening in the trunk pipelines. So again, a lot of nuances are around that blending percentage. Also, like Mr. Akhil mentioned, that in his pipelines, he is confident that at least up to 8% is likely to happen. Of course, subject to a lot of tests to be done on the ground. But again, it all depends on the age, about the metallurgy, and a lot of other aspects, what kind of gases or, the composition inside it are. So I think over the time, as the panel discussed, the testing infrastructure will be extremely important to come to the conclusion where and how much percentages could be considered.
European Union is mandating 5% very soon. When I say soon means in a year's time. But we'll see. And that will be real testing. But as I said, India is still, we are 4 years away and we have to do our own test campaign.
Yeah. Good afternoon. I'm Dr. Ajit from Good Life Mobility. My question is to Dr. Pratibha. So when you have such a new technology where material-based solution for automobiles or maybe other application, there is a constant requirement of flow of gas. So can with this kind of technology, can constant flow of hydrogen gas can be assured? If you can help me.
So we already have so these technologies which I am mentioning, we have already gone to TRL 4-5. We have also, so one of my student, he will be presenting here in both hackathon as well as posters will be there. We have already demonstrated, we have proof of concept. We had the trial runs for 60 kilometers of a scooter, and now we are moving on to light commercial vehicles and later for heavy duty vehicles also. So that flow we have ensured, because that actually is the characteristic of the system as well as the materials which we are using. That is the most important. So all that before even go to that particular level, we have to do test all these things off board and integrate. So that has to work well, that we ensure.
Thank you.
Hello. Can I speak?
Oh, one more question. We
Yeah,
asked for
I
two.
was.
Okay, we have yes, volunteers. Just last question, please, because we are between you and
Yeah,
lunch. So we don't want.
I was just trying to, it was a music to my ear when he talked about the percentage, Mr. Mehrotra, 8%, 20%. I would like to have, I'm from all oil companies. I would like to have 100% blend in my gas pipeline, hydrogen blend. But more and more you increase the blend, there is a propensity of more and more leakages, more and more bleeding that has been observed because of the higher compression, the higher flow rate, which is needed when you increase the dosage. That is a major issue because safety, as we talk about hydrogen, is unlike LPG. LPG is settling in a bottom, being heavier. Hydrogen goes up. Suppose the hydrogen leaks in a room, I will not be even knowing hydrogen is, there is a leakage. It will be burned, I will not be knowing the flame. There is no flame at all. So that safety aspect, especially in Indian conditions, when you talk about pipeline, if there is a leakage, anything has been done to address that in those pipelines. Secondly, if you talk about pipe gas, I'm talking about same context. Pipe gas, if you blend 2%, 5%, or even 8%, if you're not using your gas, you are out of the house for 1 month or 2 months. When you come back, is there a possibility of hydrogen and gas getting separated in that? And you light the burner, hydrogen is up, catches fire, and don't even know what is going to happen. Is it there a possibility?
So again, I'll repeat, we have not done this test in India. You can read the Future Grid report, which is public in UK and it's well documented.
they have done a rupture test, and they have found after compression also they found that it catches fire at the same time and which natural gas was doing till a blend of 25%. So there are a lot of tests being done. As I said, your concerns are valid, and we need to do our own tests. That's why I said, and validate all this kind of, right? While the world is working towards that, we need to pick up those tests from them and can validate that, right?
So, very valid points. Safety is paramount, and that is what I think one round of the questions was exactly around it, that how safety concerns should be factored in when the various solutions are being developed. I must also say that PNGRB is also very actively looking at safety aspects. Some of the things like you mentioned about the, colorless flame and all. So there are certain solutions to it that you add a chemical to, the flame, and the flame in one of the experiments have been blue. So there are various ways to handle it, but of course, everything comes with a lot of testing and confirmation that yes, it's safe to be utilized. Because as an end consumer, as a homemaker, I'm making some meal in my home. I don't know whether it's hydrogen or PNG or something else. I'm completely oblivious of that part. So we have to have that particular customer base in our mind. Absolutely, very, very valid points. And I
To
think,
add,
yeah.
until 20%, I have witnessed the test myself in UK. In a burner, normal burner, the flame is still the same color. I can tell you. They have shown me that.
So everything has to be customized, of course, for India, but this gives us more confidence that yes, there is a possibility. How do we bring it to India? But thank you so much, and this was a pleasure to have the company of all these five eminent panelists, and of course, a very lively audience. You are still not hungry, it seems. I could hear the applause, so which is very good. Over to you.
Well, as we gather those pearls of wisdom from the illustrious panel, may we take a moment to extend our token of gratitude and appreciation to the exalted panel. May I request you, the esteemed session moderator, Ms. Surbhi, to kindly felicitate the eminent panelists with a token of our deep gratitude. Many, many felicitations to Mr. K.C. Sharma, Professor Pratibha Sharma, Mr. Milind Agrawal, Mr. Savir Julka, and Mr. Akhil Mehrotra. And may I request you, sir, Dr. Arvind, Scientist D from MNRE, to kindly accord a token of appreciation and gratitude to the esteemed session moderator, Ms. Surbhi Goyal, for steering this session of deliberations. And with that photo op, we close this session, requesting all the delegates to kindly proceed to the Exhibit 14 area where lunch awaits you. And all the speakers may kindly make their way to the meeting room 18 for lunch. We sincerely thank each and every one of you who's waited all this while and been with us. Thank you very much. And we await to welcome you back the next session in different meeting rooms on level 1. Thank you.